All right, just got back from a late hockey game. It is about 15 minutes to 1. I am exhausted. Let's go. Day 20, Growth Positioning System, or GPS. It's finally time to meet back up with the elves. Oh yeah, I forgot about them. When you try to contact them, however, you get no reply. Perhaps you're out of range. You know they're headed to the grove where the starfruit grows, so if you can figure out where that is, you should be able to meet back up with them. Fortunately, your handheld device has a puzzle, or has a file, your puzzle input, that contains the grove's coordinates. Yay! Unfortunately, the file is encrypted. Boo. Just in case the device were to fall in the wrong hands. Maybe you can decrypt it. Not if it's anything good. When you were still back at the camp, you overheard some elves talking about the coordinate file encryption. The main operation involved in decrypting the file is called mixing. The encrypted file is a list of numbers. To mix the file, move each number forward or backward. In the file, a number of positions equal to the value of the number being moved. Okay. The list is circular, so moving off one end, perhaps. Great. For example, to move the 1 in a sequence like this, you would move it, I guess, 1 to the right. 7, 1, yep. To move the -2, 1 to the front, and then 2, so skip the back and then 1 before. The numbers should be moved in the order they originally appear in the encrypted file. Okay, that's easy enough. Numbers moving around during the mixing process do not change the order in which the numbers are moved. Consider this encrypted file. Mixing this file okay, great, who cares? Then the grove coordinates can be found by looking at the 1000, 2000, and 3000th numbers after the 0. Wrapping around the list as necessary. Okay, so 4 minus 3, 2, we add those, we get 3. Mix your encrypted file exactly once. What is the sum of the 3 numbers that form the grove coordinates? Okay, so mixing it once. So I'm guessing either next time through we're going to mix it an incredible number of times, or we have to figure out mixing is backwards and we have to like demix it to figure out what it was originally. Either one of those would make sense. I guess we will find out in due time. All right, let's get our puzzle input. First part, though, seems easy enough. I know, famous last words. Okay. So in order to do today's, the first thing we need to do, of course, is bring in all of our input. And the order coming in is a list of strings. Every line has its own list. And then we also are going to need to keep track of the original index. There's a couple ways to do that. One is to just try to keep 2 copies of the list and then constantly find. That's a little bit slower. And then plus, I also had a sneaky suspicion, so I went through and just clicked a couple of these at random. And so like mine, this item shows up twice. So that is not going to work. So right off the bat, I was like, okay, obviously I just need to keep the original index inside of the class itself. Not a problem. So to take everything in, I'm taking this list of strings. I'm going to use map index. Map index is basically a map that also gives you the index for the number of times it's gone through. And so I'm going to take my index, my item, and then I'm going to create a new copy of that working class with the original index and the item or the string to a long. The long is important for the second part. It was an easy enough fix to change that later. So that brings in all of our stuff into basically a giant list of coordinates, and we have a permanent way of keeping the original index, which is important. And then basically, we know we need to iterate through them. We know we need to just move through them. And I just made a move item function, which takes in the list of coordinates and the index that you want to move, which finds the item just using standard Kotlin collection find, and then gets the old index. And the old index is just the index of the item that we're going to remove, not the original index. And then the new index is going to be the index that we're going to be placing it into, which is basically where it currently is, plus its item number, modulo chords.size -1. And that was the part that tripped me up at first. So let me have an example I wrote out here. So basically, like we have this list of 1, 2, star, 4, 5. And if we have a 0, it's going to go back into where it is. It starts in the second index, ends in the second index. And then if it was a 1, then we need to move it 1 index, which is 3. If it's a 2, then it needs to move 2 indexes and end up after the 5. Now, because this is cyclical and we don't actually care what the first item is, we only care that the order is preserved. This can wind up going in the 4th spot or the 0th spot. Either one will work. And then if it was a 3, then it would go back here. But if it's a 4, it winds up back in the exact same spot. It's the same as a 0. Not a 5 is the same as 0, but a 4 is the same as 0, because once we remove this item, the list shrinks by 1, basically. So once that list shrinks by 1, we need a module off of that new list, if that makes a modicum of sense. If you have questions, comments, obviously. So after that, basically, again, our new index is going to be the old index plus the item number mod the new list size after we remove the item. And then if the new index is below 0, we're just going to add the size of the array of coordinates minus 1. We already know that it's going to be smaller than the coordinate size because we have modulated it up here. And then at that point, it's pretty easy. We just remove the old item and then add the new item. So easy peasy. And then to just do our return value, all we have to do is sum up each of those indexes. And then I will see you for part 2 in 1 second. All right, part 2. The grove coordinate values seem nonsensical. Yeah. While you ponder the mysteries of elf encryption, you suddenly remember that the rest of the decryption routine you overheard back at camp. First, you need to apply the decryption key number. Multiply each number by the decryption key before you begin. This will produce the actual list of numbers to mix. Okay. Second, you need to mix the list of numbers 10 times. The order in which the numbers are mixed does not change during the mixing. The numbers are still moved in the order they appeared in the original pre-mixed list. So if -3 appears 4th in the original list of numbers to mix, -3 will be the 4th number to move during each round of mixing. Good thing we wrote our thing the way we did. Can we just do these as longs? Is that okay? Because we modded all right off the start anyway, so it's just trying to make sure you don't do it as a loop, I guess. Whatever. And then the only thing we should do different is want to mix it 10 times. Right, so multiply by a giant number, mix 10 times, keep the orders the same. Okay. So is that easy? It's that easy. You completed day 20. Alright. Cool. Well, I guess I will see you guys tomorrow.